Okay, in question 3, we are looking at the reaction of seawater with silver nitrate. So seawater would contain sodium chloride, so the chloride ions, which would have a positive test with the silver nitrate, so you'd end up with a white precipitate of silver chloride. Obviously, remember in your specification that you need to know the test results for silver chloride, silver bromide, and silver iodide. Right? So if I asked you a different style of question and asked you to distinguish between the chloride and the bromide, the chloride would be white, the bromide would be cream. It's difficult to distinguish between white and cream using the naked eye, so you would need to use further tests, which are the reaction with ammonia, to distinguish between the chloride and the bromide. The chloride would dissolve in dilute ammonia, the bromide would not. When we are looking at writing ionic equations, what I look at is writing the complete equation. So AgNO3AQ plus NaClAQ goes to NaNO3AQ plus AgCl solid. And then just separating them into ions. So Ag plus AQ, NO3 minus AQ, Na plus AQ, Cl minus AQ, Na plus AQ, NO3 minus AQ, Ag plus Cl minus solid. Okay, the way we identify the states is by using the anagram Spanx. So all sodium salts are soluble, all potassium salts are soluble, all ammonium salts are soluble, all nitrate salts are soluble, all halides, that would be chloride, bromide, or iodide salts are soluble, with the exception of with silver. Okay, and all sulfate salts are soluble, with the exception of barium. So therefore, those tests can be used to identify the different salts, because you'd get solids, you'd get precipitates in each of those cases. Okay, so how do I convert my complete ionic equation into a simplified ionic equation? Well, the first rule is if it doesn't change charge and it doesn't change state, it is not included. So the nitrate, let's look at that one. It started off as 1 minus, it ended up as 1 minus, that is no change. It started off as AQ, it ends up as AQ, that is no change. It is therefore not included. The sodium started off as plus, it ended up as plus, that is no change. It started off as AQ, it ended up as AQ, that is no change, it is therefore not included. The silver started off as AQ, it ended up as solid, that is a change, it is therefore included. The chloride started off as AQ, it ended up as solid, that is that change, it is therefore included. So we end up with Ag plus AQ plus Cl minus AQ goes to AgCl solid. So we get 1 mark for the correct ions and 1 mark for the correct states. In the next part of the question, I want to look at question C. We can see that we're asked about oxidation states and disproportionation reactions. So the oxidation state of any element by definition is 0. Okay, so therefore Cl2, the oxidation state of Cl and Cl2 is 0. The oxidation state of hydrogen is normally +1. Okay, so the total compound HCl has 0 charge, so therefore I have to add something to +1 to get 0. What do I have to add to +1? -1. So the HCl in that context is -1. In this one, I have the Cl as +1. The reason why the Cl is +1 is because Cl is less than extra negative than oxygen. Both of them want to take a negative charge, but they can't both have a negative charge because then they would repel each other. So the hydrogen is +1, the oxygen's -2, so that gets me to -1. So the chlorine in this context must therefore be +1 to make 0 overall. In the final question, it's asking why it's a disproportionation reaction. It's disproportionation reaction because the same species, in this context chlorine, has both been oxidized and reduced. So oxidation from my anagram oil rig is loss of electrons, reduction is the gain of electrons. So chlorine going from Cl2 to HCl has gained an electron. It's gone from 0 charge to a -1 charge. It has been reduced. And the chlorine going in Cl2 to the chlorine in HOCl, or hypochlorous acid, has been oxidized. It's gone from 0 to +1. It's lost an electron, and therefore it's been oxidized.